If you're like me, you might have thought a toaster is a toaster is a toaster. There's no difference between them, even if one is beautiful and one is Breville. Hi, I'm Abby from RTINGS.com, where we've collectively eaten 650 pieces of toast, a Costco jar of peanut butter, and a tub of Nutella. In this video, we'll explore the similarities and differences between toasters, as highlighted by our new methodology created by Mike, our toaster test developer extraordinaire. We'll see whether a gimmick is a gimmick is a gimmick, or if a toaster could really be worth a $400 price tag. A toaster is a very simple input-output machine. Input bread, receive toast. Most of the time, there are some basic features, like a bagel button that sometimes turns off the outer heating elements, or a frozen button that just extends the toasting time. Then there are the browning settings used to select your preferred level of toastiness, which work by changing the length of time of each cycle. You can find this basic feature set on all 20 toasters we tested, from the cheapest Black & Decker 2-slice toaster up to the beastly 4-slice Wolf Gourmet. Of course, the presentation of these features changes depending on the brand and, of course, the price. Some, like the Sur la Table 2-slice or the Beautiful by Drew 4-slice, have touchscreen menus, while the Revolution Instaglow takes that idea to the extreme, even going so far as to eliminate the lever in favor of an automated toasting experience. And yet, despite the box and the box comes in, the internals of the toaster are pretty much the same. Nichrome wire wrapped around a mica sheet, switched on and off by a timer. But if everything is mostly the same, and all that changes are the externals, why do we see such a difference in toaster performance? To answer that, first you need to understand what we're measuring here. Our toaster tests rely on image analysis to measure a toaster's performance. To even use image analysis, we have to take consistent photos, which we do using this nifty little setup here. The photo cube has a camera and a light mounted on top, pointing downwards towards this bright green screen. This keeps the lighting and the angle of the shot completely consistent, which is what we need for image analysis to work. A tester loads up a toaster with plain white sandwich bread, since it is what Mike poetically referred to as
a blank canvas,
to see what the toaster can do. Then comes the longest part of the test. Of course, we're doing other things like recording the power draw of the toaster. Now, since we have a minute here, I'll let you in on a little thing we learned. Turns out, toasters draw a lot of power. For example, the beautiful 4-slice toaster needs about 1,700 watts to run. For context, that's roughly the same amount of power that 5 77-inch OLEDs need. A regular 15-amp circuit gives you about 1,800 watts, so there isn't much wiggle room if any other appliance is plugged in and drawing power. And if you're particularly far away from the breaker box, even upgrading to a dedicated 20-amp circuit with a smaller gauge wire can't save you, no matter how many times you install it. Trust us, we tried to build a test kitchen on the opposite side of the office from the main panel. The distance proved to be our greatest challenge as we experienced a voltage drop that meant all of our 4-slice toasters were just lightly warming the bread instead of actually toasting it. We opted for this mobile setup to solve that issue and be right next to the panel. Once the toast pops, we remove it, place it in the cube, and voila. Now we do that for every marked setting on every toaster. Once we've collected all the images, the fun begins. Mike's script then crops the toast image, isolating it from its green screen background. The script then cuts the crusts off and turns it grayscale. From this image, we can evaluate the toaster's range, evenness, and consistency. We evaluate the range by comparing the distribution of the pixel values to a distribution curve of the target toast setting. A pale toast setting has significantly higher pixel values, or in layperson's terms, you'd see white, like you do here. Well, burnt toast has lower pixel values. And we're comparing the toast image to these histograms to see if the toast can even achieve those toasting standards. Most of the toasters can, and do it well. Nearly half of them score a perfect 10. But some, like the GE 4-slice toaster, simply cannot. Despite having 7 settings on the toaster, it really only has 3. Barely, lightly, and too much. For the second test, the grayscale toast is censored. Just kidding. The image is divided into 100 areas colored by the average pixel value of that sub-area. For toasting evenness, the toast is compared to itself and to toast made in the other slots. The script checks the uniformity across one face of the toast and across all faces of the toast. This lets us see whether a specific side or side of one slot heats unevenly. This is visually understandable. A 10 out of 10 toaster would give toast that is one uniform shade of gray and the same shade of gray in all slots and faces. The closest to perfect that we've seen is the Hamilton Beach 2-slice toaster, where only one little dark spot shows any sort of uneven distribution in heat. Interestingly, the Hamilton Beach 2-slice scores near the bottom for toasting range, likely due to its low power draw, meaning to get golden brown toast, you'd have to go a few rounds. At least you know it'll be a nice, even toast. The GE4 slice ends up at the bottom again because of its dark splotches and hot spots. If you're learning anything today, it's what toaster you shouldn't buy. The final test is repeated toasting, where we make repeated batches of toast at the same setting without downtime between toasting. We compare the runs to see whether the toast comes out the same each time. From doing this repeated toasting test repeatedly, we saw the visual impact of heat transfer. A toaster's performance relies heavily on heat transfer. Using the magic of IR thermography, we'll look at two comparable toasters doing what they do best. On the left, we have the Black & Decker 2-slice. On the right, the KitchenAid 2-slice. Since the KitchenAid has a reflective surface, getting a good reading with an IR camera is hard, so we've combined it with a thermocouple attached to the side to measure the heat coming out of the toaster body. As you can see, the KitchenAid gets quite a bit hotter on the outside, whereas the Black & Decker keeps the heat in. The plastic shell of the Black & Decker is more insulating than the metal of the KitchenAid, so when you use the Black & Decker, the heat is more evenly distributed within the toaster, resulting in more even toast. This changes a bit if you're toasting multiple rounds. Trapped heat can be problematic, especially if the toaster has no cooldown time. Some toasters even compensate for this by reducing the toaster time. This, of course, has some interesting consequences if a toaster overcompensates, like in the case of the GE 4-slice toaster, yet again. Each successive round of toasting gets darker and darker, but if the heat transfers readily outside of the toaster, you run the risk of an extremely hot appliance. Just look at the beautiful toaster. The hottest toaster you've ever seen at nearly 100 degrees on the outside. It's worth remembering that the toaster isn't this hot if you only run it once. Due to its high power draw and metal outer shell, it puts out a lot of heat, especially if you're firing all 4 slots at once for 10 minutes straight, which is, of course, exactly what we've done. Now, you'd expect a toaster that costs 12 times more, like the Wolf Gourmet or Revolution Instaglow, would also make toast that's 12 times better than the Black & Decker 2-slice toaster. But we've run the numbers, and this simply isn't the case. The highest scoring toaster is also the cheapest, coming in at $25 at the time of writing. And to confirm this wasn't a fluke, we bought a second Black & Decker, which performed just as well as the first. Heat transfer, power draw, and bread clamp positioning are all factors that contribute to a toaster's performance, not price. Even on the Revolution Instaglow we bought, the bread clamping mechanism is the main reason it performs so badly on our toasting evenness test, since the clamps hold the bread closer to one side. As we've seen, the GE 4-slice toaster is just abysmal. But it also isn't the cheapest 4-slice toaster, as the Cuisinart 4-slice compact toaster is $20 less and twice as good. The takeaway here is that for the most part, your toaster will toast, and whatever extra features you want won't change that fact. So the choice is yours, whether you want a little bit more, or a beautiful toaster, or a mid-century aesthetic countertop piece with smeg on the side. At the end, no. The beginning of the day, you'll still have toast. A toaster is a toaster is a toaster. Until next time, I'm Abby from RTINGS.com, where we help you find the best product for your needs. Toaster. Until next time, I'm Abby from RTINGS.com, where we help you find the best product for your needs. There's a seed in my throat. It's so dry. Okay, we got this. Do I have crumbs on my face?